Now let's discuss about facade pattern. The facade pattern is a structural design pattern that provides a simplified interface for a complex system of classes, making it easier to use and understand. This pattern belongs to the category of structural design patterns. We use the facade pattern when we have a complex system with many classes and we want to provide a simple interface to interact with this system. It helps to hide the complexity and reduce dependencies between classes, making the codebase more maintainable and easy to use. Now, let's look at an example in TypeScript to understand how the facade pattern works. The inventory class represents the subsystem responsible for managing the inventory of items in our online shopping system. It uses a private map to store item names, strings, and their quantities, numbers. The add-to-inventory method allows adding items to the inventory. It takes an item name and a quantity as parameters. If the item already exists in the inventory, it updates the quantity. Otherwise, it adds a new entry to the inventory. The remove from inventory method allows removing items from the inventory. It takes an item name and a quantity as parameters. It checks if the item exists in the inventory and if there are enough items to remove. If not, it logs an error message. The checkStock method checks the current stock, quantity, of a given item in the inventory. It returns the quantity if the item exists, or undefined if the item is not found. The payment processor class represents the subsystem responsible for processing payments. In this simplified example, it has a process payment method that simulates the payment processing logic and logs a success message. It returns true to indicate a successful payment. The shopping cart facade class acts as the facade. It has two private properties, inventory and payment processor, which are instances of the inventory and payment processor classes, respectively. The constructor initializes these subsystems. The add item to cart method simplifies the process of adding items to the shopping cart. It delegates the work to the inventory subsystem and logs a message indicating that items have been added to the cart. The remove item from cart method simplifies the process of removing items from the shopping cart. It delegates the work to the inventory subsystem and logs a message indicating that items have been removed from the cart. The checkout method handles the checkout process. It calculates the total amount based on the items in the cart, delegating to the calculate total method, and then processes the payment using the payment processor subsystem. It logs a message indicating whether the payment was successful or not. The calculate total method calculates the total amount of the items in the shopping cart. In a real-world scenario, you would fetch prices from a product catalog or database and calculate the total based on the items in the cart. In this example, it uses fixed prices for simplicity. The client code demonstrates how to use the shopping cart facade. It creates an instance of the shopping cart facade and then adds items to the cart, removes items, and finally checks out. The facade simplifies these actions for the client, hiding the complexities of inventory management and payment processing. In summary, the facade design pattern simplifies the interaction between a client and a complex subsystem by providing a unified and easy-to-use interface. It abstracts away the intricacies of the subsystem, promoting modularity, maintainability, and ease of use in software systems. In this specific example, the facade pattern simplifies the management of an online shopping cart by encapsulating inventory management and payment processing, making it more accessible to clients.